All right, a couple quick review problems here. Hopefully review. Keeping my fingers crossed that they're review. Should be review. Problem here is you can't have the square root of 7 on the bottom of a fraction. That's what caused all that snow in New York. Having square roots on the bottom of the fraction. So what do?
Times the bottom by itself and the top by itself.
Yep. So you get the square root of 14 on the top. And the bottom you just get 7. And then you divide the 14 by 7 and get the square root of 2. Is that what you do here?
Yeah.
You just leave. You can't divide a number that's inside of a square root by a number that's not inside of a square root. So that would be about as far as you take that one. You. You want to simplify it. Oh yeah, definitely. Good question. What about this one? The cube root of 3 over the cube root of 6. I'm open to suggestions. Okay, now there's that. Okay. Well, I could think of a few ways that a student might want to try this problem. Here's one way. This would be the long way, but it would work. Here's one way. You can multiply it by the cube root of 6 over the cube root of 6. But remember, since this is a cube root, it's going to take more than just 2 cube roots. How many is it going to take? Come on, we talked about this. Not last time, the time before last. It's going to take another one. So here's one way I suppose you could do this problem. This would be a bit of a longer way, but it would eventually get you to the right answer. Because what is the cube root of 6 times the cube root of 6 times another dang cube root of 6?
6.
So it would work. I personally wouldn't have done it this way. There's a shorter way. Here's what I might have done. What about combining this into one big giant cube root? How would that have helped?
So you can like divide the top and the bottom.
Yeah, 3 over 6 just becomes 1/2. And then I would separate this back into 2 cube roots. The cube root of 1 over the cube root of 2. What is the cube root of 1? Oh, come on, what's the cube root of 1? 1. So it's 1 over the cube root of 2. Now we just have smaller numbers we're dealing with. Now, we're still not quite done. We've got this pesky cube root of 2 on the bottom. So I tried to explain a bit of a shortcut to you. I'm not quite sure how many of you really caught on to this. But rather than doing this, rather than multiplying it by 2 more cube roots, I myself would have considered all of the perfect cubes. 8, 27, 64, 125, and so on. Oh boy. There it is. 8 is a multiple of 2, true or false? 8 is a multiple of 2. True? So I would have multiplied this by the cube root of 4. Why the heck would I multiply that by the cube root of 4? To turn this into the cube root of 8. So all you have to do is multiply it by 1 cube root instead of 2 identical cube roots. It's a little quicker. So we get the cube root of 4 divided by the cube root of 8, but the cube root of 8 is simply 2. The cube root of 8 is 2. So you get the cube root of 4 all over 3. Come on, guys. That was supposed to be a review problem. Here's one more quote-unquote review problem. What about the square root? Ooh. What about that? These are just a few review problems that we need to get through before we actually get into the new part of the lesson. What do you think? Exactly. That's exactly right. Because what would happen there? A lot of things simplify, don't they? Like 2 over 12, that becomes 1 over 6. And then the x on the top, and we have an x squared on the bottom. X over x squared. What happens there? We just have an x on the bottom. So now we have the square root of 1 divided by the square root of 6x. The square root of 1 really is just 1. You don't even need the square root of 1. You just need 1. Do you remember what it's called when we try to get rid of a root on the bottom of a fraction? It has a special name. Starts with an R. Rationalizing. This one needs to be rationalized. So we multiply it by the square root of 6x over the square root of 6x. So we get on the top the square root of 6x all over 6x. Oh, and would you look at that? Those cross out so nicely, right? No, they don't. Anywho, those are some of the things you already should know how to do regarding rationalizing. We need to take a look at a few different types of problems. Like this one. 2 divided by 1 plus the square root of 5. Now, I don't want you to write this. I want you to watch. No writing. Just watching. No texting. It's like you guys can't go longer than 10 seconds without texting on a phone. Is it a necessary bodily function like breathing or blinking? For some of you guys, it's like a necessary bodily function. Are your hearts going to stop beating if you don't touch your phone every 10 seconds? I'm being serious, because it's quite ridiculous how subconsciously dependent some of you are on checking your phone every 5 seconds. I don't know. I'm just saying. It's to an outside observer watching somebody who can't help themselves but every 5 seconds touch their phone. Looks pretty ridiculous. So, anywho, I'm getting off my soapbox now. Check this out. If you just try to multiply by the square root of 5 over the square root of 5, does that do the trick? Does that get rid of all of the roots in the denominator? If we tried to multiply here, you would get the square root of 5 plus the square root of 25 if you distributed. That doesn't get rid of all the square roots. The point I'm trying to make is this problem's a little bit different. We still have to rationalize.
Times the multiply by the entire 1 plus root 5 times 1 plus root 5.
You're really close. That's why the very last part of last lesson we talked about the conjugate. Think about question 3 on the quiz here. Where are you? Here it is. Weren't these two conjugates right here? And what happened when we multiplied these two together? Canceled out all the roots. And we were left with negative 23, I think, on this one. That's why we learned about conjugates. So write this little phrase down. If the denominator contains a, oh, I'm going to use a big word here. Buckle up. A binomial. Well, we better Google that word. What's a binomial? Two terms. Does this denominator contain a binomial? Yes. Did any of these denominators contain a binomial? No. If your denominator contains a binomial, multiply by the conjugate of the denominator. You always multiply by the conjugate of the denominator. Because sometimes you can have a binomial in the numerator, and that's fine. So let's give this problem a try. So we have 2 divided by 1 plus the square root of 5. And then we got to multiply it by the conjugate of the denominator. So the denominator has a conjugate, and it is 1 minus the square root of 5. But that also has to be done to the numerator as well. You've got to multiply the same thing on the top and bottom. So in the numerator, just distribute the 2, and you get 2 minus 2 root 5. I'm going to take a little diversion here for a second. Sorry. I want you to watch this. You don't need to write this down. This was your quiz question. It was 2 minus 3 root 3 multiplied by 2 plus 3 root 3. Wasn't this your quiz question? Knowing that these are conjugates, you could have shortened the multiplication process down a bit. Here's what I mean. If you were just to multiply this using the traditional distributive way, 2 times 2 is 4, 2 times 3 root 3 is 6 root 3, negative 3 times that's negative 6 root 3, and then here you get negative 9 times the square root of 9 when you multiply here and here. Knowing that these are conjugates, though, the middle terms are always going to cancel each other out. Always. If you're multiplying 2 conjugates together, the middle terms are always going to cancel each other out. So what I'm getting at is you don't have to do this multiplication here or this multiplication here, because they're just going to cancel each other out. You following what I'm saying? So if we were to try this problem again, knowing that they were conjugates, myself, I would have just done this. 2 times 2 is 4, and then negative 3 root 3 times 3 root 3 is negative 9 square roots of 9. That's all you would have to multiply, knowing that these are conjugates. Right? Because the square root of 9 is just 3. Negative 9 times 3 is negative 27. 4 minus 27 is negative 23. You don't need to worry about these 2 middle terms, because they would just cancel each other out anyway. So getting back to our problem, if you made sense of what I just said, aren't these 2, you see where my mouse is right now? Aren't these 2 conjugates? So when you're multiplying them together, you don't need to do the whole distributive property. You just need to do 1 times 1, which is 1, and the square root of 5 times negative square root of 5. That's just negative. It's negative square root of 25, which is just 5. So all you get is 1 minus 5 in the denominator. So now we have 2 minus 2 root 5 all over negative 4. Now your Math Excel online homework's pretty dang picky. Would you agree?
Yeah.
It would not accept this. What are we missing? Take a look. This actually happens quite a lot for some reason on this section for these problems. Take a look at this arrow and that arrow. Do they have anything in common? Do they not both have a 2? Here's what you're going to have to do, you guys. And even if this were a test question on an exam, I would still have to dock off a point for leaving it like this because it's not fully simplified. Here's what you would have to do. You factor out a 2 from the numerator, and that leaves you 1 minus the square root of 5 all over negative 4. You factor out a 2 from the numerator, and you're left with 1 minus the square root of 5. Why would you factor out that 2? Other than it was just super fun to do. Come on, don't be shy. You know the answer. What does this 2 now do? It simplifies with part of the denominator. Doesn't 2 over 4 simplify to something? So then you would say that this 2 can simplify with that negative 4. So you'd have 1 minus the square root of 5 all over negative 2. Now, I need your eyeballs up here for a second. I'm going to move back over to a blank screen. Let's say that you'd solved a problem and you ended up with this. 4 plus 4 square roots of 3 all over 7. Let's say at some point in a problem you ended up with this. Could you still factor out a 4? You still could, but then does the 4 have anything that simplifies with the 7?
No.
So then I wouldn't expect you, and I don't think the math homework would either. If this is where you are, then you just leave it, because 4 doesn't simplify with the 7. You see the difference there? Now here's the other thing, and this is kind of goofy. I would take this right here for full points on a test. Your math online homework, I don't believe, would like this answer. For some reason, most textbooks don't like to leave a negative sign in the denominator. It's not a problem or anything, I guess it doesn't look that good. So I would imagine if you type this into Math Excel, they would say, sorry, that's not correct, or whatever it says. What could we then do? We could multiply by negative 1 on the top and bottom. So that would give a positive 2 on the bottom. And you'd have to distribute that negative 1, so you'd get negative 1 plus the square root of 5. That would be the answer you'd want to type in. Crazy, huh? Okay. We're actually going to save that one until just a second. Here's one we need to try. Here's an example. Three root 2 divided by the square root of 5 minus the square root of 2. This root in the numerator is not a problem. It's okay to have a root in the numerator. These down here in the denominator, that's the problem.
Would you do it like
Still multiplied by the conjugate, which is square root of 5 plus the square root of 2. Got to do the same thing to the top and bottom. So you multiply the square root of 5 plus the square root of 2. Here's another thing I'm going to tell you, and this might help some of you be a little more accurate. You guys listening carefully? Okay, I need you to listen very carefully to what I'm going to say. If you're multiplying conjugate pairs together, this only would be a good idea with conjugate pairs. Do you understand what I mean by conjugate pairs? If you're multiplying conjugate pairs together, your calculator can do that. Okay? You can type in a square root of 5 minus a square root of 2 in one parenthesis, and then in another parenthesis you can type in a square root of 5 plus a square root of 2. And would you look at that? Your calculator can do conjugate pairs. Okay? It wouldn't be any help to you at all to try to simplify this in the numerator on your calculator. This you're going to want to do by hand. Okay? Honestly, though, it takes just as much time to type this into your calculator than it does to do by hand. But anyway, in the denominator, if you multiply the square root of 5 times the square root of 5, what do you get? You just get 5. What about the square root of 2 times the square root of 2? Come on, man. It's the square root of 4, but that's just... So it's 5 minus 2, and then 5 minus 2 is... That's where the 3 came from. It takes no less time or more time to do this by hand than it does on a calculator. In the numerator, you got to distribute this little term there. So we're going to get 3 square roots of 10 plus 3 square roots of 4 there's a couple of different ways we could proceed here. Probably, what is the square root of 4? That's just 2. And 2 times 3 is 6. So let's go 3 square roots of 10 plus 6 now. There we go. Final answer. We typed this into Math Excel, and guess what it would say? Sorry, your answer is incorrect. It would probably tell you something like your answer is equivalent to the simplified form, but anyway, this is not fully simplified. Because this 3 can cancel with that 3 and simplify part of that 6. So, in the numerator, if you factor out a 3, that's going to leave you the square root of 10 plus 2 all over 3. And boom! See you later, 3s. Answer is the square root of 10 plus 2. Well, we're ready to take off the training wheels. Open your books. You're going to fly solo for a minute. Yeah. Just right here, because the whole thing is being divided by 3, not just this first term. The 6 is also being divided by 3. Another way you could think about this, these two things right here are exactly the same thing. So you can cancel those, but then that still becomes a 2. You got your books? All right, open them. Page 250.
I think it's page 250. Oh, I was one off. It's 251. Right at the top of 251, you see how it says problem 6? Got it? Try that one. Page 251. The problem 6. Got it. It's a lot like this one we just finished.
Okay. Check it out. Some of you got it. Some of you are really dang close. There's just one teeny tiny thing. Oh, you can't see. Come on. So you've got to start by multiplying by the conjugate. It's the square root of 3 plus the square root of 5. So now in the denominator, if you multiply, you're going to get the square root of 3 times the square root of 3. Square root of 3 times the square root of 3. Come on. That's the square root of 9, which is 3. Then you minus, we've got the square root of 5 times the square root of 5. That's the square root of 25, which is 5. So you have 3 minus 5. In the numerator, and 3 minus 5, just I'm going to change that to negative. That's just negative 2. The numerator is going to give you 2 square roots of 21 plus 2 square roots of 35. Next thing to notice is that this piece up here and that piece up here, they both have a coefficient of 2. So I would factor that out. That leaves you the square root of 21 plus the square root of 35 all over negative 2. And here's the mistake. It's a teeny mistake. It's not a huge deal, but it's still a mistake nonetheless. This 2 cancels with that 2, but it doesn't cancel with the minus sign. The minus sign is still there. So it's really a negative 1 on the bottom. Alright? So you have the square root of 21 plus the square root of 35 all over negative 1. It's not a huge deal. I probably would give you full points on a test, but your homework's not going to accept this. You can't have a negative 1 really on the bottom of a fraction. So multiply it by negative 1 over negative 1. So it'll be negative square root of 21 minus square root of 35. Okay? Let me just show you real quick what your homework's going to look like, or what some of your homework looks like for 4 and 3. So you can realize just how easy it is, and you think, why didn't I start this sooner? Dang, this is easy. Yo. Yes. I'll get to that in a second. Like this one here. 4 root x minus 8 root x. That takes all of a half a second to solve. What's the answer? Negative 4 root x. Easy problem. Question 2. This is kind of like our quiz question. You've got to simplify. That's 3 root 3. 108 divides by some kind of a perfect square. But anyway, that's not super difficult. The first division problem you have looks like, where are you? This one. 7 divided by square root of 2 plus 1. You multiply the top and bottom by its conjugate. Not super tricky there. Here's another multiply. No, that's an add. This is like a 10-second, even less than that. What's 8 root 10 plus 9 root 10? 17 root 10, another easy one. Here's one you guys can do in your head. Maybe some of you can do in your head. Aren't these conjugates?
Yeah.
What's 4 times 4? Square root of 8 times the square root of 8 is just 8. So this is 16 minus 8. So the answer is 16 minus 8 is 8. That one some of you could probably just do in your head. There's not quite a conjugate one. We need a divide one. Come on now. Here we go. What about that one? Is that any different than the ones we just practiced?
No.
You still multiply. Which conjugate though? The one on top and one on bottom? Always the denominator. Multiply that by the conjugate of the denominator. So this homework set, pretty easy. Just got to sit down for 20 minutes and actually do it.